Goldman Sachs says 300 million jobs are at risk from AI. The Bureau of Labor Statistics says AI-exposed occupations have lower unemployment than non-exposed ones. Both of these are from recent data. Both are true. Welcome to economics, where everything is simultaneously on fire and fine. So how can both be true? How can the jobs most exposed to AI be doing better than the ones AI hasn't touched? The answer isn't spin. It's not propaganda. And it's not that one of them is lying. The answer is that the word risk is doing a tremendous amount of heavy lifting in that Goldman Sachs headline. And once you understand what it actually means mathematically, the panic starts to look a little different. Not gone, different. Today we're going to do something radical. We're going to look at what the math actually says about AI and jobs. Not vibes, not headlines, not some guy on Twitter who just discovered ChatGPT and is now convinced civilization has 6 months left. Actual frameworks that economists have been developing since 1817. Because it turns out people have been terrified of machines taking their jobs for over 200 years, and mathematicians have been quietly working out what really happens the entire time. Let's start with the granddaddy of all automation economics, comparative advantage. This idea comes from David Ricardo in 1817. Which means economists figured out the answer to will machines take our jobs before the light bulb existed, before the telephone, before anyone had a job that involved staring at Slack messages pretending to be busy. Here's the setup. Imagine two countries, England and Portugal. Portugal is better at making both wine and cloth. Better at wine, better at cloth, better at everything. So England should just give up and become a theme park, right? Wrong. Ricardo showed that what matters isn't who's better in absolute terms, it's who's relatively better. If Portugal is twice as good at wine but only slightly better at cloth, then Portugal should specialize in wine and England should specialize in cloth. And both countries end up richer by trading. The key insight is relative advantage, not absolute advantage. Now replace Portugal with AI and England with you. Even if AI is better than you at literally everything, writing, coding, art, therapy, filing taxes, folding laundry, explaining comparative advantage in YouTube videos, you still have a job. Because the economy doesn't ask who's best, it asks what's the cheapest way to get everything done, and the cheapest allocation always involves everyone specializing in their relative strength. David Ricardo figured this out about wine. You're welcome. Now, comparative advantage tells us jobs won't disappear entirely, but it doesn't tell us what happens to individual jobs. For that, we need a more modern framework. Enter Darren Acemoglu and Pasquale Strapo, who developed what economists call task-based models. And this is where things get really interesting. The key insight is deceptively simple. Jobs are not atomic units. You are not an accountant the way a hydrogen atom is a hydrogen atom. You are a bundle of tasks. A typical job might involve 20 distinct tasks, some routine, some creative, some interpersonal, some analytical. AI doesn't walk in and delete the job. It automates specific tasks within the job. Maybe 8 out of 20. The job changes, but it doesn't disappear. Think about what a radiologist does. Reading an X-ray is one task, but they also consult with patients, discuss treatment options with surgeons, handle ambiguous cases, mentor residents, and navigate the deeply human question of how to deliver bad news. AI might take over the pattern recognition piece, and honestly, it's already pretty good at spotting tumors. But the radiologist doesn't vanish. They do the remaining 12 tasks, which are now more valuable precisely because the routine part is automated. The human judgment becomes the scarce resource. Economists call this the complementarity effect, which is a fancy way of saying your job got a robot assistant and now the non-robot parts matter more. This leads us to something genuinely counterintuitive. The Jevons Paradox, also known as wait, that can't be right. Let me check the data again. William Stanley Jevons noticed in 1865 that when steam engines became more efficient and used less coal per unit of work, total coal consumption went up, not down. Why? Because cheaper energy meant more things became economically viable to power. The efficiency created more demand than it saved. The same thing happens with automation. And the most beautiful example is the ATM. When ATMs rolled out in the 1970s and 80s, everyone said, well, that's the end of bank tellers. Makes sense, right? A machine that literally does the teller's job is right there in the name, automated teller machine. But what actually happened? The number of bank tellers went up. ATMs made it cheaper to operate a bank branch. Fewer tellers per branch, yes, but way more branches. Net result, more tellers employed after ATMs than before. The machines that were supposed to kill the job created more of it. Same thing happened with spreadsheets and accountants. Excel was supposed to make accountants obsolete. Instead, there are now roughly 3 times as many accountants as there were before spreadsheets. They just hate their jobs for different reasons. When you make something cheaper to produce, you don't just get the same amount cheaper, you get way more of it. Demand is elastic. This isn't guaranteed to happen with every job AI touches, but it's happened so consistently throughout history that ignoring it is like ignoring gravity because you think this time the apple might float. Okay, but here's where the AI doomers push back. They say this time is different because AI is improving exponentially. And they're not wrong about the capability curve. AI capabilities are genuinely improving at an exponential rate. But here's what the headlines miss. Capability is not the same as adoption. And adoption doesn't follow an exponential. It follows an S-curve. An S-curve starts slow, accelerates in the middle, then flattens out. Every technology in history follows this pattern: electricity, cars, the internet, smartphones. And the reason is boringly practical. Even when the technology is ready, organizations aren't. There's regulation to navigate, integration costs to bear, trust to build, legacy systems to replace, and an almost infinite amount of organizational inertia to overcome. Anyone who's worked at a company that still uses Internet Explorer knows exactly what I'm talking about. The gap between AI can do this task in a lab and companies have actually restructured their operations around AI doing this task is measured in years to decades, not months. So when someone tells you AI capabilities are exponential and therefore job loss will be exponential, they're confusing 2 different curves. It's like saying because a car can go 200 miles per hour, traffic will move at 200 miles per hour? No. Traffic moves at the speed of the slowest car trying to merge, which is always a Prius doing 37 in the left lane. Now let's talk about that Goldman Sachs number. 300 million jobs at risk. This is where base rate neglect comes in, one of the most common statistical errors in public discourse, and one that headline writers exploit ruthlessly because fear gets clicks. What does at risk actually mean in the study? It means contains tasks that are technically automatable by current or near-future AI. That's it. It does not mean will be eliminated. It does not mean will be eliminated soon. It does not even mean will be significantly changed soon. It means the job has automatable components. By that definition, literally every job that involves writing an email has been at risk since 2022. Here's what the historical base rate actually shows. Of jobs identified as at risk from automation in previous technological waves, roughly 5 to 10% experienced actual displacement per decade. So let's run the numbers through the funnel. 300 million at risk. Maybe 60 million significantly changed in the next decade. Of those, maybe 15 to 30 million experience actual displacement, meaning their current role no longer exists in its current form. And of those, the vast majority are re-employed within 2 years, often in roles that didn't exist before the transition. 300 million becomes scary. 15 million over a decade with most people landing on their feet is still a problem, but a very different kind of problem. A policy problem, not an existential crisis. And that brings us to the real risk, the one the math actually does worry about. It's not whether automation creates more jobs than it destroys. Historically, it always has. It's not whether displaced workers eventually find new employment. Historically, they mostly do. The real risk is speed. Automation creates more jobs than it destroys in the long run. But the long run is a phrase economists use to mean a time period during which you might lose your house. If displacement happens faster than retraining, if jobs vanish in 2 years but reskilling takes 5, you get a brutal transition window where real people suffer real consequences. The math on this is straightforward and sobering. Displacement speed tracks with the exponential technology curve, but retraining speed is roughly linear. It's bounded by how fast humans can learn new skills, which hasn't changed much since the invention of the classroom. This mismatch is where policy matters. Not because the system won't equilibrate, but because wait for equilibrium is not an acceptable answer when someone can't pay rent. So what does the math actually say? Let me give you the honest summary. Comparative advantage says you'll have a job even if AI is better than you at everything. Task-based models say your job will change but probably won't disappear. The Jevons Paradox says automation often creates more employment, not less. S-curves say adoption will be slower than the headlines imply. Base rates say 300 million at risk really means maybe 15 million displaced over a decade. And transition dynamics say the real danger isn't the destination, it's the journey. The math says AI won't take your job, but it will change it. The question isn't whether you'll work, it's whether you'll be ready for what work becomes, and whether we build systems that help people cross the gap between the old work and the new work, rather than just shouting about 300 million jobs while the data quietly tells a different story. If this helped you think more clearly about the math behind the headlines, hit subscribe to Improper Integral for more visual math and science that cuts through the noise. And share this with someone who could use a little less panic and a little more calculus in their life.